Welcome to MENG 4313, Section 031. We'll be covering fin tubes heat exchangers. This is Teammate. I am Sergio Hernandez.
Steve Strahan.
Van Burnett.
Milot Seamus.
Samuel Morales.
Michael Geddes.
The following material will be covered for fin heat exchangers. Types of fin tube heat exchangers, parts of AC unit, types of flow, mixed and unmixed flow, design and why or why not to use a fin heat exchanger, specifications, and simulation.
Fin tube heat exchangers. Use of a fin tube exchanger works especially well for an air heat exchanger. A fin tube adds a lot of heat transfer surface area for the fluid outside the tube, which is usually air or some other gas for a fin tube heat exchanger. For a liquid-liquid heat exchanger, the use of a fin tube isn't normally needed because the heat transfer coefficient for both sides of the heat transfer surface is relatively high. For an air heat exchanger, however, one of the fluids is air or some other gas. The air side heat transfer coefficient will be much lower, so additional heat transfer surface area as in fin tube exchanger is very helpful. The overall flow pattern for a fin tube heat exchanger is often cross flow, but it can also be counterflow or parallel. We will talk about the three of the most widely used types in the following slides. Pictured here is a louvered fin tube heat exchanger, or also known as an interrupted surface fin heat exchanger. Interrupted surfaces achieve heat transfer enhancement by the continuous growth and destruction of laminar boundary layers on the interrupted portion of the geometry. One of the most used examples of the interrupted surface is the louvered fin. The louvered fins gained popularity in the 1950s that is maintained today. Today, the use of louvered fins has become popular in the fields of automotive, heating, cooling, air conditioning, power plants, and food industry. Pictured is a typical structure of the louvered fin. Another type of common fin used in tube heat exchangers is a radial fin tube heat exchanger. And finally, a flat fin tube heat exchanger, commonly used in the AC industry, evaporator and coolers.
Also, the heat exchanger system contains fans that is located in the middle of the system, as shown in the figure to the right.
Next, let's talk about types of flow in a cross-flow heat exchanger. First, we have mixed flow. The primary characteristics of a mixed flow type include the absence of internal channels which direct the flow and prevent mixing. This can be troublesome since the fluid is allowed to undergo turbulent mixing, in which the temperature profile in the transverse or cross-flow direction spreads evenly throughout the flow, preventing temperature variation in this direction. In addition to this issue, since there are no channels to direct the fluid particles are free to move in the main flow direction instead of in the transverse direction. Think of this as if you were running diagonally across the street instead of right across it. Combining this issue with the turbulent mixing mentioned before basically neutralizes temperature variations in the transverse direction, and the only appreciable temperature variation will be in the main flow direction. With this said, having a mixed flow type only allows for temperature variation in the tube or main flow direction. As far as pros and cons of this flow type are concerned, we can conclude that the absence of internal channels makes design and construction of a vessel to incorporate this flow type much easier and possibly cheaper. Also, due to this absence, there are less restrictions to the flow, allowing for higher flow rates with less parasitic frictional losses and pressure drops. In contrast, the absence of internal channels can prove problematic, as it does not allow for control of the direction of the flow paths, ultimately affecting the temperature profile and distribution of the flow. Lastly, there will be less heat transfer surface area due to the lack of internal channels, in addition to a lower thermal effectiveness when implementing this flow type.
Another type of flow is unmixed. In a cross-flow heat exchanger, it is said to be unmixed since the plate fins force the fluid to flow through a particular inner fin spacing and prevent it from moving in the transverse direction parallel to the tubes. These fins or channels act to increase the heat transfer area. Some pros of the unmixed flow prevents merging of fluids, and the unmixed flow yields the best thermal effectiveness. They also have low weight per unit heat transfer, and they're very versatile, and they can be used in various applications. Also, some cons are they have a more complicated design versus just a regular mix. And there are some challenging calculations that need to be done to get accurate results. So it's very hard to pinpoint where you're going to be. And there's also some mixedness that does occur, regardless if it says it's unmixed, at the tube edges and the plate edges.
Some pros and cons for fin tube heat exchangers. One being the increase in surface area due to fins causing an increase in heat transfer rate. They can be very small if application needed. You can use air or water depending on application, and this will help in corrosion factors and cleaning and maintenance. A few cons: they're very expensive because of the complex fins that you can use, and they have a very large resistance to flow. So this causes the fluid to have a low pressure and low velocity.
In a fin tube heat exchanger are the fin tubes, where seamless metal tubes are wrapped around with transverse fins that helps increasing the surface area necessary for transfer of heat across the wall of the tubes. In a fin tube heat exchanger, it is the process liquid that is pumped through the tubes from one end, which then moves through successive rows of tubes to the other end. During the process, depending on the application, the liquid either picks up heat or loses the heat to the air or gas on the other side.
The following shows geometric dimensions of fin tube heat exchangers, parameters and specifications, tube row arrangement, tube position, fin material, fin thickness, fin pitch, surface configuration, number of tubes per row. Number of tubes row, tube outside diameter, tube inside diameter, row pitch, tube pitch, total tube length, face coil height, face coil width. Specifications of fin tubes continue. The following shows recommended fin spacing based on operating conditions such as temperature. The following shows operating conditions used for a simulation using refrigerant R410A. This concludes fin tube heat exchanger presentation. Any questions? The following is the appendix shown where information and data was gathered from.